Alright, now let's quickly write the Java implementation for the algorithm that we have discussed previously for finding the minimum value in a sorted rotated array. So here, first of all, let me read the length of the array so that we can use it wherever we want. For example, to handle the first scenario where the array is sorted but not at all rotated. In this case, to find the minimum value, I will basically compare the value at 0th index with the value we have at the last index, which is nothing but length of the array minus 1. If at all the value at 0th index is smaller than the last value, obviously that 0th index value itself is nothing but the smaller value. In that case, I will simply return the 0th index value itself. Okay, if this is not the case, that basically represents that the array has been rotated at least once. Here we need to apply the binary searching technique to find the minimum value. So for binary searching, here I'm going to define the start and end range, and along with that I will also define the middle, and I'm initializing it with 1. Now here we will simply run a loop as long as the start is less than end. Once we get into the loop, we will calculate the middle. Middle is nothing but start plus end divisible by 2. Once we get this middle, here our aim is to find the minimum value. So as part of our logic, our aim is to move the start pointer to the index where the minimum value is there. So here the comparisons that we do will be, whatever the value we have at the middle index, first we will compare it with the value we have at the end index. So if at all the value at the middle index is greater than the value we have at the end index, since the array is sorted and rotated, now the comparison that we are doing is the value at the middle is greater than value we have at the end index. Since the array is sorted and rotated, the smaller value will always be lying on the right part of the array in this case. To continue the search on the right part of the array, I will update the start with middle plus 1. Okay, if this is not the case, the other scenario will be till middle, anywhere there could be a minimum value. That means till middle, from start and till middle, any value can be a minimum value. So to continue that search, here we will simply update the end with middle itself. Here the middle can also be the smallest value. That's why the end will be pointing to middle index itself. Once we complete executing this while loop, in searching all the possible ranges, in the end, whatever the value we have at the start index, right, it basically represents the minimum value in a sorted rotated array. So we will simply return that in the end. This is the simplest code for finding the minimum value in a sorted and rotated array. So let's just try to call this function and validate it on the input that we have here. Here the input that I have passed is 4, 5, 6, 2, 3. So here the array has been sorted and rotated twice. So in this sorted and rotated array, the smaller value is 2, right? So if I execute this now, the output should be 2. So that is what we have got. Let me just expand this so that we will get it here. And let's just say I have removed this 2 also. Now the smallest value inside this sorted rotated array is 3. So if I run this now, run as Java application, see the output that we have got is 3. Okay. And let's just say the array that I have passed is sorted itself, not at all rotated. Technically speaking, the array is rotated 0 times, right? So in this one, the smallest value is 4. So if I run this right now, the output should be 4. Okay, so that is what we have got on the output as well. So whatever the logic that we have written for finding the minimum value in a sorted rotated array using binary search is working fine. You can test out the other scenarios by using the link and going to codingpal.org. There we have listed some more additional test cases that I have not tested here. You can test them out too, as well as you can find the brute force solution as well. But anyway, that is the logic for finding the minimum value in a sorted rotated array using binary searching technique.